Hi everyone. Today we are going to look at chapter 6.3 zero force members. But before we go to the chapter 6.3, I'd like to make an announcement about the midterm exam number 2, which will be held on April 21st, which is a Tuesday. It starts from 11 a.m. until 1 p.m. So there are 2 hours window. You can find the midterm exam number 2 on the blackboard. It covers from chapter 4 through the chapter 6. This is an open book test and you may need an engineering calculator. The midterm exam number 2 has a 20%, which is a very significant amount for your final score. And also in this case, I want you to submit your problem solving process through the link. So you get an extra credit as well as a partial credit. This is a tentative schedule, but I think we can make this schedule on time. So April 21st would be a good time. So after finish the chapter 6, we are looking at the structural analysis, which is a truss. So yeah. So let's look at the zero force members. Today's lecture is relatively short because this is very simple and very easy topics. But it's very useful. So once you can identify zero force member in truss, then your calculation is much easier. So that's the reason why we need to identify zero force members. Let me ask you 2 questions here. The first question is, using this free body diagram, you can see the right hand side, there is a free body diagram. You find that force BC is a negative 500 Newton. Okay, so it seems like this free body diagram is our assumption before we get the actual the magnitude and the sign. So the negative sign means that actually the direction FBC is opposite, right? So this one should be the opposite direction with 500 Newton. Okay, the question is, member BC must be in. You can see that there is a pushing force toward the joint B. So this member BC must be in compression. Okay, let's go to second question. When supporting the same magnitude of force, truss members in compression are generally made thicker, thinner, the same size compared to the tension. So what did I say last class? The member is in compression, then that member should be made more thicker so that it can hold the weight, right? Okay, so here there is a definition about the zero force members. So if you look at the image here, there are many members, but you can see that some members there are no external forces, and also there are no support reactions. So for example, you can see joint D and joint A. There are 2 members, which is AF and AB, DE and CD. Those 4 members have no support reaction and no external load. So here you can see that the definition of zero force member is if a joint has only 2 non-collinear members and there is no external load or no support reaction at that joint, that means DE, CDC, and AF and AB, this member does not have internal force. Okay, this we called zero force members. So we can simplify this problem like this. So we can find only 1, 2, 3, 4, 5. These are 5 members. That's it. So we can simplify the problems because these members does not have force. This is a zero force. Okay. Another example here is that you can see that this joint CD, they are collinear. Okay. There is no external load on the joint D and C. Then this third member, this is a non-collinear member. This one is also the zero force members. Okay, again, there are 2 of the members are collinear. These members are collinear, right? DC, let's see. If you look at that, if you look at the joint D, this member DE and DC, these 2 members are collinear. These 2 members are collinear. And there is no external forces on the B. Okay? There is no support reaction at the D. So in that case, the third member, which is this one, the third member is a zero force member. The same thing for the joint C, CD and CB. These 2 members are collinear. Okay, they are on the same line, which is collinear. The third member, this one, is a zero force members. Let me show you why these are zero force members. So if you look at the point D, this is the free body diagram about the point D. And you can draw the orientation, like in this case, the textbook use, okay, this direction is x-axis, and the perpendicular, this direction is y-axis. You may realize that this entire truss is in equilibrium, then every single joint is in equilibrium. So that's why force DE and the force DC should be the same, but opposite direction. That's the reason why we can cancel out these 2 forces. That is, you can see the sigma Fy should be equal to 0. So these 2 forces must be the same and the opposite direction. How about the dA? There is only 1 force associated at the x-axis direction. So that's the reason why this force should be equal to 0. That's why the point D is in equilibrium. So this one should be equal to 0. About the point C, it's the same concept. For the y-axis direction, there are 3 forces associated. But for the x-axis directions, let me see, there is only 1 force associated, which is Fc sine theta. Fc sine theta should be equal to 0. So that means the theta is not 0. That means Fc should be equal to 0. Okay, so that's the reason why these one and these one are zero force members. Then you can ask, oh professor, why zero force member is necessary? Because it's it's complicated and it makes a problem more complicated. And then why we need a zero force member? Yeah, that's a good question. So, even though the zero force member does not have any forces, but this one is great for the stability and the rigidity of the truss. So, for example, when you think about when we building a bridge, the bridge must be hold a certain weight. Also, the bridge must be very stable against a very strong wind or waves, right? So we don't know how much wind can blow. It depending on the natures. So the zero force member, even though there is no forces associated, but this one would increase the stability for uncertainty cases. So this is a little bit provide more rigidity of the trust against the uncertain situations. Okay, so that's the reason why we add these zero force members in the truss. So let's solve the one example here. The question is, so if you look at this truss, this is a simple truss, and you can see that there are some support reactions at A and C, and there are external forces at joint D. But if you look at the joint B does not have a support reactions, as well as there is no external forces. Okay, so in this case, we can say that which one is the zero force member? Yes, that the member BD is a zero force member. So we can omit this member BD during our calculations. Right, so let me solve this problem. Let's take off the keyboard. Let me draw the free body diagram in this one. This is a pound force, and this is a roller, and point C is pin jointed. There's some dimensions. This is 4 feet. 4 feet. Okay, this one is 4 feet. So since member BD is a zero force member, we don't need to think about the member BD. Okay, even though there is a B here, there is no forces associated at the joint BD. Okay, now we can find the support reactions. Since this entire truss is in equilibrium, there should be some support reaction at point C and point A. Let's see. We can calculate that sigma moment at point A should be equal to 0, right? Because this truss is in equilibrium, this equation must be satisfied. However, if you look at that 450 pound force, this force create is it clockwise or counterclockwise? This is a counterclockwise rotation. Okay, so 450 times the perpendicular distance is 4 feet. That means the support reaction at point C must be downward. Why? That's why that's the way we can cancel out this equation. So So cy create a counter, no, never mind, cy create a clockwise rotation, so it's minus cy times the perpendicular distance, in this case is 8. So this one should be, oops, okay, 0. cy should be 225 pound force if we round to the nearest integer. So since cy is 225 pound force, which is downward direction, then support reaction at point A, which is ay, this one should be upward direction with the same amount, 225. And there is another support reaction at point C, because C is pin jointed. So since this one only associated with x-axis direction, so Cx should be 450 pounds. Okay, so we defined all the support reaction and the external forces. Remember, this joint A is supported by roller. Roller has only one support reaction, that is a vertical support reaction. Pin joint has two support reaction, which is horizontal and vertical. Okay. Alright, so let's move on. I think we can start with any joint because there are only two unknowns. Let's choose point D. Point D is here, and there are two members and one external forces. We don't know the direction of the internal force, whether this is in compression or tensions. Let's say let's assume these two forces are compression. Okay, force AD and the force CD are in compression. This is our assumptions. Okay, we will figure out whether this is right or wrong. So for the point D, joint D, we can use a equilibrium equation. Sigma fx should be equal to 0, sigma fy should be equal to 0. For the x-axis direction, if we can set the orientation like a right hand direction is positive x, the upper direction is positive y, then for the x-axis you can say, okay, negative 450, because this one is directing left hand direction, and plus FAD. You may realize that based on these dimensions, we know the angle here, which is 45. This is 45. Also, this is 45. This one should be 45. Okay, so member FAD times cosine 45. What else? Minus CD cosine 45. This one should be equal to 0. For the FY, for the y-axis direction, we have two positive things, FAD sine 45 plus FCD sine 45. This one should be equal to 0. from the second equation, we can say that oh no, never mind. From the first equation, we can express in this way. First, AD cosine 45 is equal to FCD cosine 45 plus 450, right? Since FAD cosine 45 and FAD sine 45 are the same, so we can put this to here, okay, to the second equation. So we can express like this: 2 times FCD cosine 45, because this sine 45 and cosine 45 are the same, so we have a 2 FCD sine 45 or cosine 45, okay, so plus 450 is equal to 0. FCD, in this case, we can find that, oh, this is a negative sign, minus 318 pound force. Since we have a negative sign here, we have to realize that our assumption was wrong. FCD is not a compression. This one is tension. So direction, this direction. So FCDC is 318 pound of force, and this one should be in tension. Okay, so we got a negative sign here. FAD, we can find that FAD is this one is a positive value, 318 pound of force, and this one should be in compressions. So FAD, this one is 318 pound of force, and this one is compression. So we find this one is compression, and this one is in tension. Okay, I guess this one is also in tension. This one is compression. Now we can move on to the member joint A. Okay, joint A. So I think we can just use one equation here. Sigma fx. So minus. So AD is 318 pound force. So this is negative sign. Minus 318 pound force times cosine 45 plus, we don't know, the first AB, this one should be equal to 0. So FAB is 225 pounds, which is a positive direction, this way, this direction. That means this member AB, this one should be in tension because it's pulling. This is the pulling force from the member joint A, so this one is tension. So what? This is compression, this is tension, this is tension. The same amount. So you can find the answer in the next page. Okay. Okay, let me go back to unplug my keyboard here. Okay, the last question is just a small quiz, okay? So if you see the right hand side, there is a simple truss there, and there is external forces, which is force P, downward direction to the joint A. The question is, if the height of this truss has been decreased from H to 0.9 H, so the H was it was 1 H here, but now we have a reduced height, which is 0.9. So that means the width is the same, but we have a little bit lower height compared to the previous one. So which one of the following statements is true? Note that this width is the same and the load is the same. The load is also the same. Then in this case, what is the true? Okay, A, force in all its members have decreased. Force in all its members have increased. And C, force in all its members have remained the same. And the last answer, none of the above. Which one is the right answer, guys? The answer is B. All forces in the members have been increased. I would like to let this problem for you, so you can think about how the answer B is the correct true. I think you can understand and you can get a right answer B, because this is a small simple geometry equations, so you will realize. So today we learned zero force members. Thanks for watching this short video. Have a great day.